The topic for today is PIC 18 MSSP module in I2C mode, part 1. Now in part 1 we are going to study the registers and then the different modes of operation, that is the slave mode and master mode, we'll study in the other parts. The Master Synchronous Serial Port, that is MSSP module, is a serial interface useful for communicating with the other peripherals or microcontroller devices. These peripheral devices may be serial EEPROMs, shift registers, display drivers, A to D converter, etc. The MSSP module in I2C mode fully implements all master and slave functions and provides interrupt on start and stop bits in hardware to determine free bus in case of multi-master function. The MSSP module implements the standard mode specification as well as 7-bit and 10-bit addressing. In today's video, we'll see the part 1 of MSSP module in I2C mode. Only we'll see the different registers used in this module. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed to our channel, kindly subscribe and press the bell icon. The topic for today is MSSP module in I2C mode, register part. Let us start with the introduction or overview of the MSSP module. See, the MSSP module is a serial interface for communicating with other peripherals or other microcontroller devices in a system. Now these peripherals may be serial EEPROM, because this is a serial interface. We can communicate with the serial EEPROMs, shift registers, display drivers, A to D converters, etc. All these are the serial devices. Then the MSSP module can operate in one of the two modes: serial peripheral interface, that is the SPI mode, and the inter-integrated circuit I2C. So in I2C mode, it has full master mode and there is a slave mode. Now already we have discussed the serial peripheral interface mode for this MSSP. So we'll discuss the I2C interface, that will be the register part in this today's video. So the I2C interface supports the following modes in hardware: master mode, multi-master mode, and the slave mode. So these modes will be discussed in the upcoming videos. Introduction to I2C module. Now the I2C module, it will fully implement all master and slave functions and provide interrupt on start and stop bits in hardware. So then once start and stop bit interrupts, will be able to determine a free bus in case of the multi-master function. In the multi-master mode, we'll have to determine a free bus, then only the communication will be possible. The MSSP module implements the standard mode specifications as given, and here the 7-bit and 10-bit addressing both are possible to implement both. Then 2 pins are used for the data transfer. One is the serial clock, so SCL. So this will be will be making use of the port B pin RB1 for this. So these are the different, it's all the pins of PIC 18 family processors. They are multiplexed. That's why here we have shown RB1, AN10, INT1, SCK and SCL. Out of this, we are going to use the SCL part, that is the serial clock part. That will be the input. And the second pin is the serial data pin, that is will be using the port B RB0 pin. So this pin, it is also multiplex pin with different functions, AN12, INT0, then FLT0, SDI and SD. We will be using this part of the pin. So when we want to use these pins must be input, and this is done with the help of the TRIS bits, that is the direction bits for a port B. Let us see how it can be done. A port B is a 8-bit bidirectional port, and the corresponding data direction register is TRISB. So when we are setting the TRIS bit is equal to 1, then it will make the corresponding port B pin as an input. So here in this case we are going to use the pin RB0, or we call it in this case it is function is SDA. So when it is used as input, you can see the IO type is I2C, and here the function will be I2C data input in MSSP module. So input type depends on the module setting. So depending on the different modes of the module, this input type will change. So we'll be using this pin as an input for the I2C data input. Then the second pin which we are going to use is the SCL. So when we configure it by using the TRIS bit 1, then we'll get this functionality, that is I2C clock input in MSSP mode. So we'll be using the SCL and SDA, these two pins for the I2C mode of the MSSP. Then let us go to the registers part. Now MSSP module has 6 registers for I2C operation. The first 3 registers, that is MSSP Control Register 1, MSSP Control Register 2 and MSSP Status Register. Now these are control and status registers in I2C mode and are used to configure MSSP in the I2C mode. And here the SSPCON1 and SSPCON2, these are readable and writable, and this pin, this register SSPSTAT, that is the status register, it is 6 bits are read only and only the upper 2 bits are read write, and the other 3 registers, they are necessary to implement the I2C mode. So this is shown in a simplified block diagram. and we'll discuss these three registers. That is the SSPBUF, then SSPSR and SSPAD after the discussion of the block diagram. So here is the block diagram for the MSSP in I2C mode. Here you can see these are the two input pins, SCL and SD, serial data and serial clock. And then we have the SSPSR register, that is the shift register for shifting the data in or out, and is this SSPBUF register. Now this is a buffer register to which data bytes are written or read from. So the data bytes will be written to or read from this buffer register. This is the internal bus, and here we have the SSPA double D, that is the SSP address register that holds the slave device address when MSSP is configured in I2C slave mode, and when MSSP is configured in master mode, the lower 7 bits of SSP add act as a baud rate generator reload value. So that reload value will be used for the baud rate generation. Then these are the start and stop bit detect module. So this will be say it will be set or reset the bits of the status register, and that will be used for during the multi-master mode. Then in receive operations, SSPSR and SSPBUF together create a double buffered receiver. So here the double buffered receiver will be created with the help of this two together, and the complete byte it is transferred by SSPBUF and SSP. Interrupt is set during transmission. SSPBUF is not double buffered, it is it will be single buffer. So here there is a shift clock for shifting, and this two will be say for write and read, there will be buffering data. So this is the overall block diagram of the MSSP, and then let us go to the different registers which are used for configuring the I2C. Here we have the status register, SSPSTAT. So it is again a 8-bit register. The bits are, first bit 7 is SMP, that is the slew rate control bit. So in both the modes, master or slave mode, one means will have the slew rate control disabled for the standard speed mode, that is 100 kilohertz and 1 megahertz. These are the standard speed modes. Whereas if it is 0, then slew rate control enabled for high speed mode. So that is 400 kilohertz. So the slew rate control bit will control the slew rate. And then bit 6, that is the SMB bus select bit. So if it is 1, the SMB bus specific inputs will be enabled, and if it is 0, it will disable the SMB bus specific. Then bit 5, that is the data address bit. So when it is high, it will be for the data. When it is low, it will be for the address. So 1 means indicates that the last byte received or transmitted was data, and 0 indicates that the last byte received or transmitted was address. And in master mode, it is reserved. Only in sleeve mode will be either data or address. Then let us go further. Bit 4. So this is the stop bit. If it is 1, indicates that stop bit has been detected last, and if it is 0, means the stop bit was not detected. Then bit 3 is the start bit. So it indicates that start bit has been detected last, and 0 indicates that it was not detected. Then bit 2 is for the read write information bit. So again, 1 means read and 0 means write. In slave mode, it will indicate this, and in master mode, 1 means it will transmit is in progress, and 0 means transmit is not in. So master mode will be say the data will be transmitted, will be in the transmit, whereas in slave mode it will be just following the master. Then bit 1, that is the update address bit. So 1 indicates that the user needs a update address in the addresses SSP addresses, and 0 means address does not need to be updated. And then last bit here, it is buffer full status bit. So in transmit mode, the SSP buffer is full if it is 1, and if it is 0, SSP buffer is empty. And in receive mode, 1 means SSP buffer is full, but it does not include the acknowledgement and stop bits, and 0 means SSP buffer is empty, does not include acknowledgement. So in this way, the status register will have the information about the status, and different bits will be used for different purpose. Then let us go to the SSP Control Register 1, SSPCON1. So again, now this we had discussed when we have discussed the SPI mode, but here the functionalities for the I2C mode are different. That's why we have to discuss them again. So first is bit 7, that is write collision detect bit, WCOL. So it will be, now if it is 1, then a write to the SSPBUF register was attempted while the I2C conditions are not valid for a transmission to be started. So that is how this will indicate that this attempt were done. So in order to clear it, you have to write the instruction for that must be cleared in the. Then 0 means there is no collision. Then in slave transmit mode, 1 means this buffer is written while it is still transmitting the previous word. and then 0 means no collision. So, and in the receive mode, this is a don't care because it is not receive mode. Only during the transmit mode will be used for detecting the collision. So, because the bus is only a single bus with 2 wires, so if the different devices try to use it at the same time, it will lead to collision. Then bit 6, there is receive overflow indicator bit. So one means a byte is received while SSPBUF register is still holding the previous byte. So it should be cleared in the software. And 0 means there is no over. Then in the transmit mode, this will be don't care because the receive overflow will occur in the receive mode. Then let us go to the next bit 5, SSPEN, that is Master Synchronous Serial Port Enable bit. So this is enables the serial port and configures the SD and SCL pins as a serial port. It's an important pin. And 0 means it will disable the serial port and configure these pins as IO port. So RB0 and RB. So that functionality. Then bit 4 is the SCK release control bit. So in slave mode, 1 means it will release the clock and 0 means it will hold the clock. So when it holds the clock low, that means it is used to ensure that data clock will be stretched and this the data setup time has to be taken care. Then in master mode it is not used. Then bit 0 to 3, these 4 bits, they are for the mode select of the Master Synchronous Serial Port MSSP. So here 1111, it will indicate the I2C slave mode 10-bit address, and of course the start and stop bits interrupt enabled. Then 1110 will indicate I2C slave mode 7-bit address, and of course the start and stop bits, they are also enabled here. Then 1011, it means I2C firmware controlled master mode. So in this case it is only the master mode, slave is idle. Then 1000, this is the master mode, and 0111, that is the slave mode 10-bit address, and 0110 I2C slave mode 7-bit address. So these are the different mode select, and depending on this mode, the data will changing for each of them. Then let us go to the second control register, MSSP control register, that is SSPCON2. So the 7th bit is the general call enable bit. So this will be for the slave mode, because slave mode will have to give general call. So for that, this bit is used for enabling that general. It is unused in the master mode. Then bit 6 is for the acknowledge status bit. So 1 means acknowledge was not received, 0 means acknowledge was received. And then bit 5, there is acknowledge data bit. So 1 means not acknowledgement, 0 means. So when we have studied the I2C, you can refer to that video. The acknowledgement is necessary for the communication. Without that, you have to also see the different formats we have discussed in the previous video. Then let us go to the bit 4. So acknowledge sequence enable bit. So that will be used for the initial acknowledge sequence on SD and SCL pin. And here the acknowledge data bit will be transmitted. Then 0 means acknowledge sequence is idle. Then bit 3, that is receive enable bit. So it is 1 enable receive mode for I2C, and if it is 0, receive will be idle, so it will not be able to receive. Then bit 2, that is the stop bit condition. So P is for the stop, so P enable, stop bit condition enable bit. So it will 1 means it will initialize stop bit condition on SDA and SCL pin. 0 means the stop condition is idle. Then bit 1 is repeat start condition. So in case of the repeat start, we'll have to make use of this. So here initiate repeat start condition on SDA and SDA pin. So whenever you want to send, the same master wants to send the data again, at that time this will be used. Then bit 0, that is start condition enable or stretch enable bit. So it will initiate the start condition on SD and SCL pins and automatically cleared by the hardware. Then 0 means start condition. So these are the different control registers and the status register. Then let us see the overall operation of the MSSP. The MSSP module function, they are enabled by the SSPCON1 bit 5. That is what yes we have already discussed. So this is pin should be 1, then only the SSP module will be selected for the I2C mode. Then the SSPCON1 register allows control of the I2C operation. We have seen these 4 bits, SSPCON1 bits 0 to 3. They are used for selecting the particular mode. So we have the master mode, then slave mode, we have 7-bit address, and another is 10-bit address. And then again in slave mode we have the 7-bit address with start and stop bit interrupts enabled, and 10-bit address with start and stop bits enabled. And one more mode is there, that is firmware control master. So here it will be only master mode there is. Then the selection of any I2C mode with these bits will force the SCL and SDA pins to be open train. So if these pins are not programmed as input by setting the appropriate, say, TRSC or TRSB or TRSD, these are different ports which are having the data direction register as TRSC, TRSD, and TRSB. We have discussed with the TRSB. So to ensure proper operation of the module, pull-up registers must be provided externally to the SCL and SDA pin. This is necessary, otherwise it will unnecessarily create problem. So this we had discussed in the previous videos. So this is simply we have discussed the different registers used in the MSSP I2C mode. So with this we come to the end of this video. If you have any queries, you can Facebook, Twitter, Gmail or Instagram. Then if you like the video, press like button, share with your friends and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon to get notifications for our future video. And thanks for watching. Have a nice day.